I'll sign in on Kevin's account. He's got the professional one that doesn't have time limit. So this is chapters 1 and 2 of your Thanatochemistry book. And chemistry is very important to us as embalmers because you have to understand how your chemicals that you use work, how they work inside of the body. And so we start with general chemistry because in order to understand how our chemicals work, you have to understand the difference between physical chemical changes that are caused by like physical properties like gravity. Think of when we did chapter 5 and embalming, and we talked about physical versus chemical changes within the body. A chemical change is what's going to produce new products. And once we have that basic understanding of general chemistry, then you can understand inorganic chemistry because move from general, this is a survey class, so it moves very fast. We do a little bit of general chemistry and then we move to inorganic chemistry because inorganic chemistry, you're looking at acids, bases, salts, and oxides. But the reason we as embalmers need to understand inorganic chemistry is because you've got to understand water corrective chemicals later on. We use hard water, which has deposits of calcium and magnesium, and this promotes blood clotting. So you've also got to understand surface tension, which is a property of water, which is an inorganic material. Surface tension, we have surfactants in our fluids to reduce surface tension so that our chemicals can actually make contact with the body tissues. And then once we understand inorganic chemistry, then we move on to organic chemistry. This is where you're learning about different chemical groups and properties. And this is what will lead us to embalming chemistry later on, understanding what a surfactant would be, what a humectant would be, all these different things, perfuming agents, things like this. We have to understand how they work. And once we have that general understanding, we also go back to biochemistry, where we talk about like acids and lipids. And so all of this does relate to us as embalmers. So it's very important as we move through this class. While some of the concepts may sound strange because we don't study chemistry every day, it actually does relate directly to what we do in the prep. So chemistry is a branch of science that is the study of matter and the changes that matter undergoes. Matter is anything that has mass and takes up space. And historically, chemistry has been divided into two categories: organic chemistry, which would study molecules and compounds that don't contain carbon and hydrogen together. And inorganic chemistry would be, I said that backwards. Organic chemistry is a study of carbon-containing compounds and molecules. Inorganic is generally thought of as not containing carbon, but more specifically, they don't contain hydrogen and carbon together. So we'll go through that again. So organic versus inorganic chemistry. Organic compounds are much more complex. They're much larger than inorganic. Organic is going to be carbohydrates, lipids, proteins, and nucleic acids. Inorganic compounds, here we go, so I don't mess up myself again. They don't contain carbon and hydrogen together. So this can be your water, salts, acids, bases, and also oxide, which is oxygen and another element. So these are your definitions that you want to know. Organic chemistry is the study of certain carbon compounds. It's much larger and more complex. Inorganic chemistry is the study of compounds usually containing elements other than carbon, but occasionally carbon does pop up, but it won't contain carbon and hydrogen together. Biochemistry is another branch of chemistry that studies compounds produced by living organisms. That's where the bio comes from. And then we have embalming chemistry, specifically to us, it's the study of the chemical processes involved in dead organic matter in terms of decomposition and preservation. Thanatochemistry, so the prefix thanato or thanos means death, so the chemistry of death. This is the study of the physical and chemical changes in the human body that are caused by the process of death. There's other divisions of chemistry, analytical chemistry, which will be concerned with qualitative and quantitative aspects. Qualitative is concerned with descriptive things, like what is it, whereas quantitative is how much is there. So it's concerned with the amount. And then there's physical chemistry, which are the fundamental laws and theories as they relate to different types of bonds that occur in molecules and compounds, chemical structure, and the composition of substances. So how does embalming chemistry relate to the traditional division of chemistry? There's certain aspects of inorganic, organic, and biochemistry that all relate to embalming and the changes that occur to the human body during the process of death. Remember, death is not an event, it's a process that happens, but also postmortem, after death. So chemistry is our basis for embalming. We are essentially chemists. As we study chemistry, we'll talk a lot about measurements. So the way that we make measurements is comparing a known quantity to an unknown quantity. So chemistry is experimental science based on comparing things and measuring things. So chemistry is a study of matter, anything that has mass and occupies space, and the changes of matter. And when we talk about that, we're going to talk about states of matter. There's technically 4, but we're going to talk about 3 of them: solid, liquid, and gas. The 4th one is plasma, but that's really related to like energy of stars. So we're just not even going to talk about that. So matter is anything that has mass and occupied space. This can be seen and unseen things. Inertia is just a term you might want to be familiar with, which is the law, Newton's law of motion, because we'll talk about types of energy. Mass is the actual measure of inertia of matter. So how much matter is in the object. This is different than weight. Weight is specific to the measure of force exerted on an object by gravity. So when we talk about weight, it's everything earthbound. So like my weight on Earth would be like 150 pounds. But in space, that's not going to be my weight because it's 0 gravity. I would still have the same amount of mass, though. So weight is specific to gravity, measure of that on an object. So the composition or the nature of matter is going to refer to its state. It's the forces that hold its part together and chemical bonds. So the nature of matter is the composition of a particular kind of matter, whether something is a solid, a liquid, or a gas. qualitative properties, so forces that hold its part together, and observable properties, so describing them, how much is there, and the forces that hold the element together are referred to as chemical bonds. For example, a hydrogen bond, which would be water. Uh, this is an image of the three states of matter. Solids are rigid, they have a fixed shape and a fixed volume. So like this cup is solid, right? The stapler is solid. Liquid is not rigid. It doesn't have a fixed shape, meaning it'll take the shape of whatever container that holds it, but it does have a fixed volume. So like I couldn't put 16 ounces of water that's in this bottle in an 8-ounce cup. There's no way to compress that. But gases have that quality of compressibility. So gases are not rigid, they don't have a fixed shape, and they don't have a fixed volume. So in other words, it can be squashed. In addition to the states of matter, we have the changes of matter. So you have physical changes that don't actually cause a change in the chemical composition. It's still the same thing. Like ice that melts is still water, right? So it's just a physical change, a change of state. Whereas a chemical change would result in the formation of a new substance. So an example of a chemical change would be decomposition. This could be like fire as well. You can't revert back after you burn something, right? And then we have different types of energy. Energy is the ability to do work. And there's two different types that we talk about. Potential energy, which is stored energy that's released during a chemical reaction, and kinetic energy, which is the energy of motion. So to simplify this, you can see this image up here. So potential energy, picture an archer pulling bow back. So you're holding that energy. Whereas when he lets go of the arrow, the movement of the arrow would be motion, so kinetic energy. And in chemistry, of course, we talk about measurements. So we're going to talk about the metric system. And the metric system is what most everybody else uses. The US does not use it, but we do use it in chemistry as the international system of units so that we can have a unified way of measuring things. Set up using factors of 10 and your base units. So you want to note this, you need to know this. When you're measuring the length of something for chemistry, it's meters. If you're measuring the mass of something, it's kilograms. Remember, mass is not weight. Heat would be measured in calories, volume in liters, and temperature in Celsius. And this is just so scientists around the world can all communicate. This is the same concept that we use in anatomical terminology. This is your standard conversion factors for linear measurements. I'm not going to make you do this. Okay, we're not going to be converting things. We're just looking at the general ideas for the survey class. Now, in a standard chemistry class, we'd be converting. So a meter is 39.37 inches. An inch is 2.54 centimeters. A mile is 1.61 kilometers. And a cubic centimeter is 1 millimeter. Okay. I'm not going to ask you that on an exam. All right, and that's chapter 1. See, it's not as painful as people think chemistry is going to be. So what you need to know from this chapter is right here. Chemistry is a systematic study of the nature of matter and the changes that it undergoes.
It's recorded, right?
Yes, and I will post it. Matter is anything that has mass and occupied space, and matter can change physically or chemically. Chemically meaning it produces a new substance. Each division contributes to both thanatochemistry and embalming chemistry. Thanatochemistry is the study of physical and chemical changes in the human body caused by the process of death. Embalming chemistry is the study of the types of matter and changes in matter related to disinfection and preservation of human remains. And the units for measurement that we use are of the metric system. Now hang tight because we're still going to do chapter 2, which is physical and chemical changes. See it. All right, so this chapter we're talking about physical and chemical changes. So matter is characterized by two general types of properties, physical property or chemical properties. So physical properties can be observed without altering the actual composition of a substance. There's physical changes are easily reversible. So think a cube of ice melts, right? It's water. We can refreeze it and it'll go back to ice. If it's a physical change, there's no new products made. It's typically going to be just a state change. So, perfect example, ice to water, maybe it evaporates. Well, it'll still come back as water, which can also freeze. Chemical properties are observed when the substance interacts with another form of matter. So it's not easily reversed if it even can be. There's a new product formed. The reactants, which are what react with each other, chemical reactants to produce the new product, are used up during the change. Typically, chemical changes will involve heat because it's either releasing or absorbing heat. Light, sound, fizzing could occur. Electricity could be produced. A precipitate could form. And a good example of a chemical change would be like wood burning. Because once that wood is burned, that's a chemical change. It's not reversible. Examples of physical properties. So descriptive properties, typically the color of something, odor, the taste. But remember, in chemistry, we don't put unknown substances in our mouths. This is not a good idea. So typically, you don't want to smell things or taste things that are unknown. The state of matter, the melting point, which is also the freezing point, paradoxically, the boiling point, the density, and the solubility. We'll talk about these terms. Density, this is just a definition that you want to understand the general concept of. Once again, you're not going to be doing conversions or solving for things in this type of course. But density is the relationship of an object's mass between an object's mass and the volume occupied by that mass. So this would be the formula, which would be density equals mass divided by the volume. So if you have two of the three numbers you need to know, you can solve for whatever. If you're looking for the density, it's mass divided by volume. If you're looking for the mass, it's the density multiplied by the volume. If you're looking for the volume, it is the mass divided by the density. Specific gravity is the ratio, so cutting up like a fraction, of the mass of a substance to the mass of an equal volume of water at the same temperature. And because it's a ratio of two masses, it doesn't have any units, so it would just be a number. Coming back to arterial fluid, for example, physical properties of an arterial fluid. So we're just describing it, right? The color is typically red or orange. The taste is not available due to the toxic nature, so we don't want to describe that. The solubility is that it's water soluble, meaning we can dilute it in water and it mix. And the density, which if you calculate would be mass over the volume, is approximately 1.05 grams per milliliter. So whereas physical properties are kind of descriptive, chemical properties are watching things react with each other. So it results in an alteration of the chemical composition of the substance. Examples of chemical properties would be like rust, the rusting of iron, burning things, cremation is a chemical change, souring of milk, decomposition of human remains, also oxides and hydrolysis. Because remember, hydrolysis is technically the reaction of salts. And also you're dealing with electrolytes, so it'll produce electricity. And that's chapter 2. See, it's not that painful. You just have to know matter has physical and chemical properties. The difference being that during a chemical change, new substances are formed. Okay, chemistry is not going to be that bad. I'm going to stop the recording.